For years, Americans were told that electric cars would eventually become affordable. That was the promise behind the EV revolution. As batteries became cheaper, factories became more efficient, and production expanded, electric vehicles were expected to become as common as gasoline cars. But for millions of American families, that future never arrived. Today, buying a new EV still often means spending tens of thousands of dollars. The biggest obstacle isn't charging stations. It isn't driving range. It's simply the price. For many households, an electric car remains something they admire, but still can't afford. Now look at this. A tiny, enclosed electric vehicle with 3 wheels. It has doors, a roof, headlights, a digital screen, even a backup camera on some models. And in China, vehicles like this can sell for around $1,000. No, it isn't built for American highways, but that's not the point. The real question is this: if transportation can be built this cheaply somewhere else, why doesn't the world's largest car market offer anything remotely similar? Most people think they already know the answer. Cheap labor, government subsidies, unfair competition. Perhaps, but those explanations don't fully explain why China is no longer known only for inexpensive vehicles. Today, it is also home to many of the world's largest battery companies, some of the fastest growing EV manufacturers, and an increasingly sophisticated supply chain. So another question begins to emerge. If China can produce electric vehicles that become cheaper every year, why are affordable EVs still out of reach for so many Americans? This isn't a review of a 3-wheeled electric vehicle. It's an investigation into something much bigger. Are American consumers missing out on affordable transportation because building a low-cost EV is impossible? Or because the global auto industry has evolved in very different directions? And if tariffs keep low-cost Chinese EVs out of the United States, are they protecting American manufacturing? Or preventing American families from benefiting from lower prices? To answer those questions, we have to begin with one tiny electric vehicle that costs around $1,000. The impossible EV. At first glance, this little vehicle doesn't look revolutionary. It has 3 wheels instead of 4. Its battery is much smaller than the one inside a Tesla. Its top speed is limited. To many Americans, it may not even feel like a real car, and that's exactly why most people underestimate it, because this vehicle wasn't designed to compete with luxury EVs. It was designed to solve one simple problem. How can ordinary people travel from one place to another at the lowest possible cost? For decades, automakers competed by building larger vehicles with more power, more comfort, and more technology. Every new generation became heavier, more complicated, and more expensive. This tiny EV followed a completely different philosophy. Instead of asking how to build the best electric car, its designers asked how to build the most affordable electric transportation that still meets everyday needs. That single decision changed everything. A smaller battery immediately lowers cost. A lighter frame uses less material. A simpler motor reduces manufacturing complexity. Fewer electronic features shorten production time. Each decision saves only a little. But when every part of the vehicle is optimized for affordability instead of luxury, those small savings begin to add up. The result isn't just a cheaper vehicle, it's an entirely different product built for a different purpose. Perhaps this is where many of us have been asking the wrong question. For decades, much of the global auto industry focused on building faster, bigger, and more capable vehicles. China, however, often started from a different place, not how do we build the world's best electric car, but how do we build an electric vehicle that millions of ordinary people can actually afford? That difference may sound small, but it changes everything. Once affordability becomes the starting point, every engineering decision, every supplier, every factory, and every investment begins moving in the same direction. And that's what makes this little three-wheeled EV so important. It isn't simply a cheap vehicle, it represents a completely different way of thinking about transportation. But that leads to an even bigger mystery. If China only knows how to build inexpensive vehicles, why is it also producing some of the world's most advanced EV technologies? China didn't just build cheap EVs. Most Americans still see China through an old stereotype, a country that wins by making cheap products, cheap toys, cheap electronics, cheap labor. For years, that image wasn't entirely wrong. But the electric vehicle industry tells a very different story. Today, China isn't just building inexpensive transportation, it is building some of the world's most advanced electric vehicle technologies. That is where many people are still looking at the wrong picture. Take BYD. Many people know it as an automaker, but BYD didn't begin as a car company. It started as a battery manufacturer. That distinction matters, because batteries are not just another component inside an EV. They are the single most expensive part of the vehicle, often accounting for around 1/3 or more of its total cost. Instead of buying batteries from someone else, BYD spent decades learning how to design, manufacture, and improve them itself. The same is true for CATL. Today, CATL supplies batteries to automakers around the world, including several global brands. While much of the world was still debating whether electric vehicles would succeed, China was already investing in the technology that would eventually power them. The innovation didn't stop with batteries. China also pushed aggressively into battery chemistry. One of the biggest examples is the widespread adoption of lithium iron phosphate batteries, better known as LFP. Compared with traditional nickel-based batteries, LFP batteries are generally less expensive, have long cycle life, and avoid the use of nickel and cobalt, although they also involve trade-offs such as lower energy density. For many affordable EVs, those trade-offs made perfect sense. At the same time, companies like BYD introduced technologies such as the Blade battery, designed to improve safety, packaging efficiency, and durability. China also accelerated fast charging, vehicle software integration, and increasingly sophisticated driver assistance systems. Some Chinese manufacturers now offer premium EVs capable of features that only a few years ago seemed futuristic. Vehicles that can perform tank turns, luxury SUVs designed to remain temporarily buoyant in water under specific conditions, ultra-fast charging systems, advanced digital cabins. These aren't copies. They are original engineering achievements competing on the global stage. Perhaps that's the biggest misconception of all. China didn't move from cheap products to advanced technology overnight. It spent years building expertise in batteries, manufacturing, software, and supply chains until those capabilities reinforced one another. Low cost opened the door. Technology kept it open, and that's why the world's EV industry is changing so quickly. The real advantage is no longer simply lower wages or cheaper factories. It is the ability to improve technology while continuing to reduce costs. That combination is extraordinarily difficult to match. But even that doesn't fully explain China's rise, because no battery company, no automaker, and no government policy can transform an industry by itself. Behind every affordable electric vehicle lies something much larger, an entire ecosystem working together. And that's where the story becomes even more interesting. The ecosystem behind the car. When people think about an electric vehicle, they usually picture the final product, the battery, the motor, the touchscreen, the design. But by the time a finished EV reaches a customer, thousands of companies have already contributed to building it. Mining companies extract lithium, iron, and graphite. Chemical processors refine raw materials into battery-grade products. Battery manufacturers turn those materials into cells. Suppliers produce motors, wiring, electronics, and countless other components. Factories assemble everything into a finished vehicle. None of these steps exists in isolation. Each depends on the others. Over the past 2 decades, China invested heavily in connecting those pieces together. Battery factories were built close to suppliers. Suppliers grew close to automakers. Ports, railways, and logistics networks reduced transportation costs. Local governments encouraged industrial clusters where hundreds of related companies could operate within the same region. Instead of every company solving every problem alone, the ecosystem began solving problems together. That reduced costs, shortened delivery times, accelerated innovation, and allowed manufacturers to respond much faster when demand increased. This is one reason companies like BYD and CATL became so influential. They weren't simply producing batteries. They were part of a much larger manufacturing network where knowledge, suppliers, infrastructure, and investment constantly reinforced one another. As production increased, costs gradually fell. As costs fell, more consumers bought EVs. As more people bought EVs, companies invested even more in factories, technology, and research. The cycle continued. Each success strengthened the next one. This may be the most important lesson of all. China didn't become a major EV producer because of one brilliant invention, or one unsuccessful company, or one government policy. It became competitive because an entire industrial ecosystem matured together over many years. That's a very different challenge from simply building one great electric car. And it leads to another important question. If America still has world-class engineers, world-famous automakers, and some of the world's most innovative technology companies, why is building an affordable EV still so difficult? The answer lies not inside the car, but inside the cost of everything surrounding it. America's cost stack. For more than a century, the United States has been one of the world's greatest automotive powers. Ford transformed mass production. General Motors helped shape the modern automobile industry. Today, companies like Tesla continue to push the boundaries of electric vehicles, software integration, and autonomous driving. So the problem isn't that America has forgotten how to build cars. Far from it. American engineers remain among the best in the world. Its automakers continue to produce some of the safest, fastest, and most technologically advanced vehicles available, which makes one question even more difficult to answer. If America can build extraordinary electric cars, why is building an affordable one so much harder? The answer begins with something most consumers never see. Every vehicle carries far more than a battery, a motor, and 4 wheels. Behind every new car is a growing stack of costs: higher labor expenses, healthcare benefits, safety testing, environmental regulations, warranty obligations, liability risks, software development, cybersecurity, marketing, dealer networks for many legacy automakers, financing costs, insurance, logistics, supplier margins. None of these costs is unnecessary on its own. Many exist for good reasons, helping improve safety, quality, and consumer protection. But every additional requirement adds another layer to the final price. By the time a vehicle reaches a showroom, thousands of individual cost decisions have accumulated into one number the customer ultimately pays. Electric vehicles make this challenge even greater. Unlike gasoline cars, EVs rely heavily on batteries, power electronics, and critical minerals. If battery materials become more expensive, the vehicle becomes more expensive. If components travel through multiple countries before final assembly, costs increase again. If production volumes remain lower than those of conventional vehicles, manufacturing costs stay higher. This is why building an affordable EV isn't simply about designing a cheaper car. It's about reducing costs across an entire industrial system. Every factory, every supplier, every logistics network, every production process. The car is only the final result. The real challenge begins years before the first vehicle leaves the assembly line. This changes the way we think about America's position. Perhaps the United States isn't struggling because it lacks engineering talent. Perhaps it isn't falling behind because it can't invent new technology. The greater challenge is that America's industrial ecosystem was built around different priorities: large vehicles, higher performance, premium features, higher consumer expectations. Those strengths helped create some of the world's most desirable automobiles. But they also make producing an ultra-low-cost EV far more difficult. Which brings us to another widely debated solution. If low-cost Chinese EVs create competitive pressure, could tariffs level the playing field? Or are they only addressing the symptom while leaving the underlying challenge untouched? Can tariffs solve the problem? Tariffs are often presented as a simple solution: raise the cost of imported vehicles, protect domestic manufacturers, create more American jobs. At first glance, the logic seems straightforward. If foreign competitors become more expensive, American companies gain more room to compete. But manufacturing is rarely that simple. Modern vehicles are no longer built entirely inside one country. They are assembled through global supply chains that cross borders many times before reaching the customer. Even some of America's most successful technology and automotive companies remain connected in different ways to manufacturing ecosystems centered in China. Tesla has long operated major production facilities in Shanghai while sourcing numerous components and materials through global suppliers connected to China. Apple assembles many of its products through manufacturing partners that have built extensive operations there. Many battery materials, electronic components, rare earth magnets, and processing capabilities still pass through Chinese companies or Chinese-based supply chains before becoming part of products sold around the world. This doesn't mean every component comes from China, but it does illustrate how deeply interconnected global manufacturing has become. That is why tariffs alone cannot instantly create a low-cost EV industry. A tariff can increase the price of an imported vehicle, but it cannot immediately build a battery factory. It cannot open a new lithium refinery overnight. It cannot create experienced suppliers, trained workers, or decades of manufacturing expertise with a single policy decision. Industrial ecosystems take years, sometimes decades, to develop. They depend on investment, infrastructure, education, technology, and thousands of companies learning how to work together efficiently. Those foundations cannot be built as quickly as tariffs can be announced. None of this means tariffs have no purpose. Supporters argue they can protect strategic industries, encourage domestic investment, and reduce dependence on foreign supply chains. Critics argue they may also increase prices for consumers and slow competition if alternative supply chains are not ready. The debate is ultimately about balancing national industrial goals with the costs borne by consumers. One thing, however, is becoming increasingly clear. Tariffs may slow competitors. They may buy valuable time. But time alone does not create an affordable EV ecosystem, which leaves one final question. After all the debates about technology, manufacturing, supply chains, and tariffs, who ultimately benefits from this global competition? And just as importantly, who ultimately pays the price? The real winner. When we began this investigation, everything seemed to revolve around one unusual little vehicle, a three-wheeled EV costing around $1,000. At first, it looked almost like a curiosity. Too small, too simple, too inexpensive to matter. But after following the evidence through batteries, factories, supply chains, and industrial policy, that tiny vehicle now looks very different. It was never the story. It was the clue. The real story has always been much bigger. This has never been simply a competition between BYD and Tesla, or between Ford and Chinese automakers. It isn't even just a contest between China and the United States. It's a competition between two industrial ecosystems built around different priorities. One system has spent decades optimizing affordable large-scale manufacturing, building dense supplier networks, and lowering production costs across the entire supply chain. The other has excelled at engineering, innovation, safety, premium products, and high-value technology. Both systems have remarkable strengths. Both also face significant trade-offs, and those trade-offs are becoming increasingly visible in the global EV market. This is why the future of electric vehicles cannot be explained by a single company, a single policy, or even a single country. Building an affordable EV requires much more than designing an attractive car. It requires battery factories, reliable supplies of critical minerals, chemical refining, component manufacturers, efficient logistics, skilled workers, software developers, investment that continues for years, often long before consumers ever see the finished product. The vehicle sitting in a showroom is only the final chapter of a much longer industrial story. Whoever builds the strongest ecosystem doesn't simply lower manufacturing costs. They increase the speed of innovation. They attract more suppliers. They create larger production volumes, and over time, they make advanced technology available to more people. Perhaps that is the most important lesson this tiny EV has been trying to teach us all along. So the biggest question is no longer whether China is winning or whether America is losing. The more important question is whether ordinary consumers will ultimately benefit from this competition. If competition encourages better batteries, safer vehicles, lower production costs, and more affordable transportation, then families everywhere stand to gain. But if affordable EVs remain out of reach because industrial systems become more fragmented, supply chains become less efficient, or competition becomes increasingly restricted, then consumers may continue paying higher prices for the same basic need, getting from one place to another. That changes the way we should think about the global EV race. The real measure of success isn't simply which country exports more cars, or which company becomes the world's largest automaker. It is whether innovation eventually reaches ordinary people. Whether a teacher, a construction worker, a delivery driver, or a young family can realistically afford cleaner transportation without taking on years of additional financial burden. Let's return to where this investigation began, that tiny $1,000 electric vehicle. At first glance, it looked like an odd little machine that could never survive in the world's largest automotive market. But after examining everything behind it, we can see something else. It represents a different way of asking the same question, not how do we build the most impressive electric vehicle, but how do we make electric transportation affordable for as many people as possible? Whether America chooses to answer that question in exactly the same way as China is a decision for policymakers, automakers, and consumers. But one reality is becoming increasingly difficult to ignore. The future of the automotive industry will not belong only to the country that builds the fastest car or the most luxurious one. It will belong to those who can combine innovation, resilient supply chains, and efficient manufacturing to deliver technology that ordinary people can actually afford. Because in the end, people don't drive industrial policy, they don't drive tariffs, they don't drive supply chains. They drive the vehicles those systems make possible, and perhaps that was the real lesson hidden inside a tiny $1,000 EV all along.